Hello everyone. Today I'm going to cover how to size the ball bearing and gas bearing. The bearing vendor can help you to size the bearing when you are developing the rotating machines. But when you are working with the bearing vendor, don't assume that the bearing vendor knows everything about the bearing. So knowing the basic knowledge of the bearing helps you to facilitate the discussion with the bearing supplier, and it helps you to design a better product. Alright, let's start with defining the term NDM. NDM value is a good indicator of how fast the bearing is spinning. DM is defined as the mean bearing diameter. And the N is the machine spin speed. If you multiply the machine speed N with the mean diameter dm, it gives you NDM value. So high NDM value indicates high ball bearing surface speed. The same logic applies to DN number, which indicates the multiplication of shaft outer diameter or bearing inner diameter, D, with the machine speed, N. This DN number also indicates the bearing surface speed, but it is defined differently than the NDM number. So if the ball bearing spins fast, it means high NDM value. At high-speed operation, high inertia is generated from the balls, and that means centrifugal force are increased. This leads to higher vibration levels, which leads to higher heat buildup, and therefore reducing the bearing life. So it is important to limit the bearing NDM, the surface speed, to optimize the bearing life. So what is considered low or high NDM? The limitation of bearing NDM depends on many factors, such as what the bearing ball is made out of. For example, is the ball made out of ceramic balls or steel balls? Other major factor that affects the NDM is lubrication. So you have to understand what type of lubrication is used. Is it grease or oil? But in general, if you look at the SKF bearing manual, high NDM is considered beyond 500,000. And at these high NDM values, the operating temperature of the bearing must be given more attention, because it is spinning fast, so the bearing is getting hot. But this high NDM value in this graph is based on steel ball bearing. If you use ceramic ball bearing, you could operate your bearing beyond 1 million NDM. Of course, operating conditions such as operating hours affects what is considered high or low NDM, but this graph tends to show you typical NDM values. The low NDM area is less than around 10,000 NDM. So if you are designing the bearing with the steel balls, try not to exceed the NDM above 0.5 million NDM. Also, there are many literatures out there that provides you with bearing surface speed limitation. One example is shown in this graph. The x-axis is the rotational speed, and the above highlighted line is the approximate maximum speed of rolling element bearing. Based on this graph, you could obtain the maximum DN value for the ball bearings. Again, the DN also indicates the bearing surface speed, but it is defined differently than the NDM. The bearing DN limit is around 0.3 million DN through 0.5 million DN, based on this past literature. But this graph is based on the assumption that the rolling element bearing is using steel ball with the medium viscosity mineral oil lubrication. So if you are using ceramic balls, the bearing surface speed limit should be higher than the bearing with steel balls. because the ceramic is lighter in weight and it has smaller thermal expansion than steel. Also, if you're using grease instead of mineral oil, your DN limit tends to be lower. This past data gives you an idea where the approximate bearing surface speed limit is, which helps you to size the bearing at a first glance. Here is a useful figure that shows the bearing grease life affected by the NDM. The grease life is defined by the point in time where the grease cannot longer lubricate the bearing. But finding this exact time may be difficult to measure. But in general, a high bearing surface speed NDM tends to reduce the grease life. Please note that the y-axis is the log scale. So by linearly increasing the NDM can exponentially decrease the grease life. Alright, let's talk about how to size the gas bearings. The foil gas bearing design rule of thumbs are to keep the DN value under 3 million DN at the maximum operating speed, so that you don't encounter a thermal issue during the life of the machine. Also, keep DN value over 0.7 million DN at the minimum operating speed, so that you could lift up the shaft and have a good minimum film thickness. Here is the collection of the data points for maximum operating speed versus the shaft diameter, or bearing inner diameter. These data points are from the past literature, which reports the maximum operating speed of its machine. In a well-controlled laboratory experiments, one can achieve high maximum speed. But for mass-producing the machine, which accounts for part tolerance and production variations, it is safe to keep the DN values under 3 million DN for its maximum operating speed. This helps you to prevent bearing failure due to thermal issues. And this last slide summarizes what we've discussed today. You probably have noticed that foil gas bearing has higher bearing surface speed limit. This is because for the foil gas bearing, gas is the working fluid, so that it could operate at a higher surface speed. These NDM and DN numbers are guidelines for you to size your bearing better and faster. Alright, this is all I have for you today. If you like this video, please subscribe my channel. Thanks for watching, and I'll see you in my next video.